When you create a virtual machine, your operating system has to be installed on a virtual hard drive. The virtual hard drive comes in two formats. We can use a VHD format. Now, this is a legacy format, so this is not what you would use today. This was in 2008, 2008 R2, and Server 2012. When we moved to Server 2012 R2, we went to VHDX. Now, a virtual hard drive is a virtual hard drive. I mean, you create a virtual machine, you don't really even know or care what format virtual hard drive you have. But the difference is in some of the specs. You can have a VHD, a max of 2040 gigabytes in size. Everybody just goes ahead and rounds up and says 2 terabytes. The VHDX, a whopping 64 terabytes in size. As we said, the VHD is in 2008 up through Server 2012, so older versions of Hyper-V is where you would see that. The only time you would ever encounter a VHD now is if you had a Windows Server 2012 or older server and you want to migrate your virtual machines. Virtual hard drives are going to come with it, but you want to migrate that to Server 2019. Well, when you go through the migration, they are still going to be VHD files when you move them to Server 2019. You could simply go through a quick conversion process and just convert it from VHD to VHDX. Then you can have larger sizes and you get all the other benefits. Now, I have used Hyper-V since Server 2008, and I've never had issues with the drives becoming corrupt or anything like that. But one thing that Microsoft heavily touts for VHDX, they are much more reliable, says Microsoft. They have self-recovery from corruption issues. One concern with VHD, although it's not a problem I ever experienced, the older VHDs in Hyper-V, if you had a sudden loss of power, so if electricity went out, a power plug was bumped or something on your server, and it just suddenly lost power, if you had files being written to your VHD, they could become corrupt and have no way to recover, and your VM may fail to boot back up, once you power back on the Hyper-V server. With VHDX, Microsoft says that will not be a concern. Now, something we'll never see, we just basically take Microsoft's word for it. It uses a larger block size. Now, block size, that's a term you hear with physical hard drives. Like it has these blocks and data is written into these blocks. The smaller the block size, the more work the hard drive has to do. The larger the block size, the more data it can put in it, and it actually increases performance. So that does give us a performance increase, having the larger block size. But that's not something you configure or adjust or anything like that, just a fact. So the only configurable difference is size. Everything else, Microsoft says, these are just unmeasurable benefits. You can convert this at any time. You can go to the Hyper-V Manager and simply edit your virtual hard disk. When you do that, you can convert between VHD and VHDX, and you could go back and forth. So if this was built on an older system, it is just a couple of clicks, and you now have your VHD converted over to a VHDX. So you can do that in the Hyper-V Manager. You can manage these, and they will be visible in disk management. You can actually go to disk management on a client operating system like Windows 7 or Windows 10, and you can create a virtual hard drive directly in disk management. Disk part is just the command line equivalent of disk management. You can create this in PowerShell. There's a new VHD, and you can completely manage virtual hard drives through PowerShell. And you can also do this in the Windows Admin Center. There are also different types of virtual hard disks. Now, the type, we have a fixed. This allocates all the hard disk space immediately. Let's say this is not a virtual hard drive, but a physical hard drive. And I'm going to say it is 1 terabyte. You go through the Hyper-V Manager or disk management, and you create a virtual hard drive. We'll say a VHDX. Well, that virtual hard drive, physically, it has to be written to your hard drive. So that's where the virtual hard drive will actually live. Let's say you make this virtual hard drive 500 gigs. Now, if you make this a fixed disk, This is going to consume 500 gigs of space. So your virtual hard drive is really going to take half of this space. So when you go back to your physical hard drive and click on it on the host machine, it's going to tell you that you have this just over 500 gigs of free space left, and that this 500 gigs is actually consumed. That's a fixed disk. All the hard disk space is immediately allocated. Now, normally we don't want a fixed disk. You would only use a fixed disk for like a database. Something that will create a lot of disk activity. A lot of databases do a lot of logging. They have like these transaction logs, activity logs. It's like a SQL database or something like that. You may want a fixed database. But for most things, you want a dynamic. A dynamic is only as large as what you save into it. Now, to put a face to that, let's say we do the same thing, but I make it a dynamic. Instead of this consuming 500 gigs of space, it's only as large as what you put into it. When you create a virtual hard drive, it starts off as only 20 megs. So let's say you have saved nothing to it yet. You just created it. You only consume 20 megs of space. All the other space is still on the physical drive, and you can do whatever you want with it. But if I made this 500 gigs, that means as you save, the virtual hard drive expands and expands, but it'll never exceed 500 gigs. So let's say you go up to 200 gigs. And that's the most data you ever save, 200 gigs. Well, you can use the other just over 700 gigs for whatever you want. It would not be consumed by your virtual hard drive. So only uses the amount of space needed, and it just grows as necessary. This is the default option in Hyper-V. When you create a virtual machine, you do not have the option to choose fixed or dynamic. It's just going to be dynamic. Now, a differencing disk, that is a little different. No pun intended. I have a disk that is associated with another virtual hard disk in a parent-child configuration. Any changes made are actually written to the differencing disk, not the parent. Now, what we mean by that, I'm going to clear off all my ink here, or much of it. So we'll just clean that up a bit. Now, when I have a differencing disk, this is the parent. This runs the operating system. So we'll say Server 2019. When you install the operating system, the disk is just over 10 gigs. But I'm going to say we just made this a 20 gig drive. That's it. Then I install Server 2019. I knew the goal was to have a differencing disk. Then what I can do, I go to Hyper-V and I can create a new virtual hard drive. And when I create a drive, it's going to ask me, do you want a fixed drive? Do you want a dynamic drive? Do you want a differencing drive? If I choose differencing, it's going to ask me who the parent is. So I can select this disk that runs Server 2019 as the parent. Now they are linked together. So the OS is here, and this really has nothing on it right now. What happens, I create a new virtual machine. And I tell the new virtual machine that it needs to use this as a hard drive. When I do that, I power up my virtual machine. These disks are now linked together. This operating system here completely starts up and is running. But as it starts up, this is now read only. So every single change you make is going to be written here. So that's why they call it a differencing disk, because all the differences, once you power up, are all written here. So let's say you install some applications. Your apps would be written here. You add Windows updates. Your updates would be written to this disk. Now, if you're just using a virtual machine, you have no idea it works this way. You just start it and log in and it just works. But nothing is ever written to the parent. All your changes are written here. Now, you could do this as many times as you want. I could have another differencing disk. And I could, in this differencing disk, install some other applications. I'll say app 2. These are completely independent. So this differencing disk is linked to the parent, same as the other. I just create a new virtual machine here, and it uses this disk. They are two completely different operating systems in every way, different virtual machines. The advantage is you consume far less space because the only operating system is here. You only have one OS, but you have two different virtual machines that run independent of each other. You could have a dozen virtual machines and it would work exactly this way, where you truly have one operating system. All the other disks are differencing disks. The advantage of this is space. If I installed a full OS on each of these two drives, you would be consuming more space than having a differencing disk. The other thing we can say about this, you would never do this in a production environment. You would only do this like in a test lab or something like that, because what you have done is create a single point of failure. Even though this is read-only on this virtual hard drive, if this thing somehow corrupted itself, both of these virtual machines would cease to run. So it does create a single point of failure. So those are kind of the, I don't want to say big three. Fixed and dynamic are the common two. Then differencing, yeah, just an option for like a test lab. The last is pass-through. This just allows virtual machines to connect directly to an iSCSI drive, meaning your virtual machine now uses a physical hard drive in your machine, not just a virtual hard drive that you created. So pass through, that name truly means your virtual machine will pass through to a physical hard drive and it will have exclusive access to a physical hard drive. That's one of the big takeaways. The exclusive access. Meaning only that virtual machine would use that hard drive. So let's say you're building a SQL database server, and your database server, you know it's going to be very disk intensive. Then you can actually go buy a solid state drive, connect it to your server, and when you create your virtual machine that's going to be your SQL server, you can simply tell it that it has full and exclusive access to this dedicated physical hard drive for maximum performance. Pretty interesting.